Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. So in this question, it says that 450 people are in total, and we know that represented by 360 degrees in a circle. But what I want to do is work out what 1 degree represents. So to get from 360 to 1, we divide by 360. So we're going to do the same on the other side. So 450 divided by 360 is 1.25, or 1 1/4. So 1 degree represents 1/4, or 1 1/4 people. Okay, and we're asked to find how many people answered no, which is 140 degrees. So we want to find out what 140 degrees is. So we obviously need to times that by 140, and we're going to times the other side by 140 as well. And when we do that, we get 175. So it'd be 175 people said no. There are a number of different ways of working out this question. You can find out the amount of tissues per penny. You can work out the amount of, or the price of one tissue, or you can get all the amount of tissues into the same amount. I'm going to find out the price per one tissue, and we're going to start off with the 24. And what I'm going to do is I'm going to convert the money into pence, just to mean that we don't have as much decimal. And we're going to do 807. I'm going to divide by the 24 to find out the price of one tissue. So that is 33.625. And so I'm just going to round that to 33.63. I'm just going to round everything to 2 decimal places, which it says in the question. Next one, we're going to do the 20 soft tissues. So this time I'm going to do 683 divided by 20. When I put that into the calculator, you get 34.15, so that's already 2 decimal places. And then finally we're going to do the 15 soft tissues. So we're going to do the 623 divided by 15 to find the price per tissue. It should be 41.533 blah blah blah, and rounded would be 41.53. So if you buy 15 tissues, it will cost 41 pence. 20 tissues, it will be 34 pence per tissue, but 24 tissues will be 33.63. So that's by far the cheapest. The best value is the 24 tissues box. Now, there's such thing as buying in bulk. Generally, the more you buy of something, the cheaper it is. Don't rely on that. Both in the GCSE, both in the exam, and in real life. Sometimes in real life, if you buy more of an item, actually per tissue, sometimes it becomes more expensive, especially if there's a special offer on the smaller box. So we have an original amount, and this represents 100% of the original amount. The new price, new amount, represents 113%, because it has said that it has gone up by 13%. So it has increased by 13%. And as a value, that increase is £1,287. So it's 13% of the original. It's gone up 13% of the original price. So what we're going to do is we're going to work out what 1% of the price increase is. Instead of 13%, we're going to work out what 1% is. And we're going to do that by dividing the amount by 13, and we get 99. So 1% represents £99. So 1% of the original represents £99. But the new amount is 113%. So we need to times the £99 by 113, which gives us £11,187. So the picture is now worth £11,187. So we've got to first of all make these both the same units, because at the moment they are different units, and when we have ratios we always want to make sure that they have the same units, and then we can get rid of the units. So I'm just going to make them both into grams. I'm going to do that by timesing the right by 1,000. And the reason I've chosen grams rather than kilograms is you want to always pick the smaller unit. Otherwise you'd be left with a decimal on the left hand side, you'd be 0.2, and that can be a bit more complicated. Okay, so I'm going to remove the units now, and we're just going to focus on the numbers. So we can divide both sides by 100. Straight off the bat, so we've got 2 to 40. We can see we can divide them both by 2. And so we've got 1 to 20. And so it's 1 gram to 20 grams, or just 1 to 20. So we've got to first of all find out what the gradient is for our graph. So we're just going to pick 2 points and draw a triangle between them. So I'm just going to pick this point here and this point here. And there's no reason I picked those, just pick those at random. And we look at how far it's going to cross. So it's gone across 10. How far it's gone up. So it's gone from 24 to 36, so it's gone 12 up. And to work out the gradient, which you can call n, or you can just write out the word gradient, it's change in y over change in x. So how much has y changed over how much has x changed? So y is this one here, so it's changed by 12, and x has changed by 10. So it's 12 divided by 10, which is 1.2. Now a gradient represents the amount of change in the y per one change in the x. So for every 1 mile we travel, we're going to go up, it's going to cost 1.2 more. So the interpretation that we give for this context, because this is about taxis, is that the taxi will cost £1.20 or 120 pence per 1 unit on the x per mile. And that's true for the gradient for any context. It's for every one of this, how much of this increases, how much the y increases by. The midpoint is the halfway point between these two coordinates, and we focus on the x and the y components separately. So we're going to just look at the x coordinates first. And to find the halfway points, we use this simple formula, which basically means that we're adding the two x coordinates together, then dividing by 2. So we're going to add the 6 and the 2 together, and then divide by 2. So 6 plus 2 is 8, half of 8 is 4. So our midpoint for the x component is 4. Now we look at the y's, and we use a similar formula, but this time it's y1 plus y2 divided by 2. And so it's the y component from the first coordinate, add the y from the second coordinate. So that's going to be 14 divided by 2, which is going to be 7. So firstly, we're going to work out what the percentage increases are as a multiplier. So we start off with 100%. Jane has a 1.2% interest pay rise, sorry, and so that would be 101.2%, and we divide that by 100 to make it a multiplier. So the multiplier is 1.012, so we get the 20,000 times it by 1.012, and that gives us 240. Next we do the same for Lenny, so that is Jane. And so let's do Lenny. And so that's 100% plus the 1.5% will be 101.5%. Make that a multiplier, 101.5%. We divide that by 100. Which give us 1.015, And then finally what we do is we get the 17,000 times it by the multiplier. And when we do that, we get 255. So Lenny has 255, Jane has 240. So it says which of the employees has a larger pay increase and by how much. So the answer will be Lenny, and it's by £15 because that's the difference between these. In this question we've got euros and we've got pounds, and we're told that £1 is 2.23 euros. And we're trying to get to understand what 2,676 euros is in pounds, and we're going to do that by finding out what €1 is and then finding out how much 2,676 are. So to get from 2.23 to 1, we divide by 2.23, and we're going to do that on both sides. And when we do that, we get 0.448 blah blah blah. And then to get from 1 to 2,676, we go times by 2,676 on both sides. And when we do that, we get £1,200. So 2,676 euros is £1,200. This question seems a lot harder than it is. What I'm going to do is I'm going to start by rewriting the prime factors, but without the squared. So 2 times 3 times 3 times 5 times 5. I'm going to do the same with the other lists as well. So 2 times 2 times 3 times 11. Now I'm going to put these into a Venn diagram. And so I'm just going to draw out a Venn diagram and get my two circles, because we're going to have the 450 and the 132. So 450 is on the left hand side and 132 is on the right hand side. And we're going to start just filling out the Venn diagram. So they both have a 2 in them and they both have a 3, but 450 has a 3, a 5 and a 5. And 132 has that 2 in the 11. Now to find the lowest common multiple, what you do is you just multiply all these numbers together, and that will give you the lowest common multiple. So what we're going to do is we're going to do 3 times 5 times 5, which are the numbers on the left, times 2 times 3, which are the numbers in the middle, times 2 times 11. And when we do that, we get 9,900, and that's it. So our answer is 9,900. So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here, the question's basically asking us what can we cut all these pipes into, and they all have to be the same length. That will fit with the 25 meter and the 35 meter. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these. So 1, 2, 4, 5, 6. And so there's 7 in total. So each of these are 5 meter long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. So for this question, we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this. and like this. It could be the other way around, and it could be distorted, but it basically goes down to a point along here. It goes to infinity, and it goes to infinity along a point over here, and obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down, and this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down, but here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. I'm just going to write the question out, so we've got a little bit bigger writing to play with here. And it doesn't actually matter which method you expand these brackets with. I'm going to use Smars and Rainbows. So we multiply the 8 by the 10x, which will make 80x, and multiply the 8 by the 4, which will make 32. Now here we've got a minus 5 on the outside, so we do minus 5 times 8x, which is minus 40x, and minus 5 times minus 4, which is actually plus 20. And a lot of students will write take away 20 there, but that is a minus 5 on the outside of the brackets there. So it's minus 5 times the minus 4 there will give you a plus 20. Then 80x take away 40x, which will give us 40x. And 32 plus 20, which would be 52. So our answer would be 40x plus 52. So we're given 21 to 4 is the ratio. We're just going to have our lines in, because what we need to do is make the left hand side be 1. Okay? And to do that, for 21 I need to divide it by itself, divide it by 21, and we're going to do the same to the right hand side. So 21 divided by 21 is 1, perfect, that's what we wanted. 4 divided by 21 is 0.190 blah blah blah. It says it wants it to 2 decimal places, so it's going to be 1 to 0.19. There's an awful lot going on in this question. Whenever there's an awful lot going on, it's always best to draw a diagram. So we're going to start off at Chelton, which is a C. Then we go to Bolko, that's where we're going. And we go through Devley on the way, so we'll do D there. Distance from Chelton to Devley is 34 miles. Distance from Devley to Bovlo is 16 miles. So I'm just reading through the question, adding it to my diagram. David leaves Chelton at 9 o'clock. He drives from Chelton to Devley an average speed of 68 miles per hour. And what speed does David travel between Devley and Bolko to arrive at 9:45? So the whole duration of this, the whole thing needs to be 45 minutes, or 0.75 hours. And the entire distance is 34 plus 16, so that would be 50 miles. Okay, now having a look at this, we need to find out what time David was at Devley. So we're going to use our speed distance time triangle. So speed equals distance over time, and we're covering up the time because that's the one we want. So it's going to be time equals distance, which is 34, over speed, which is 68. So we're going to do 34 divided by 68, which is 0.5. So it would be 0.5 hours. So that would be half an hour. So we will be at Devley at 9:30. So that means we've got 15 minutes left. Okay, so we've got 15 minutes to travel the 16 miles. So this time we're looking for the speed. Okay, so it will be speed equals the distance, which is 16 miles, over time, which is 15 minutes, but we need that in hours, so that would be 0.25 hours. And so what we can do here is times top 1 by 4 to get rid of the fraction. So it becomes 64 over 1, or just 64 miles per hour. So our answer is 64 miles per hour. To find the perimeter of this sector, we've got to first of all find out the length of the arc, which will be this part here. And the formula for arc length is, first of all, we find out the fraction of the circle we have. So we put the angle over 360, and that will tell us the fraction of the circle that the sector is. And then all we do is we times that by the circumference, which is pi d. And so that's going to be 49 over 360 times pi times, and the diameter would be twice the radius. The radius is 7, so it would be times 14. When we do all of that, we get 5.986, blah, blah, blah. But that is not the perimeter yet. Perimeter needs to include, get the right ones, needs to include these parts here. So the perimeter will be the 5.986 plus a radius plus another radius. And when we do that, we get 19.986, blah, blah, blah. And we want to round it to 2 decimal places, so that will be 19.99 centimetres. So I'm just going to write this out again, just so we've got a bit more space. Okay, the way we solve this is very similar to solving an equation with equal signs, but this time we're going to do 2 tramlines because there's 3 sides of this inequality. And we need to get x on its own. So looking at the fact that we've got 3x plus, or 3x minus 5, we're going to deal with that minus 5 first. So we're going to add 5 to all 3 sides. So add 5 here. So we'll just leave 3x in the middle and add 5 to the right hand side. Now we need to get rid of that 3. So we're going to divide by 3. And again, we need to do it all 3 sides. So divide by 3 and divide by 3. So we've got x is greater than or equal to 7, and then we've got 10 is greater than x on the right hand side. There are 2 shapes we need to find the volume of. There's this cylinder here and this hemisphere here. So we might as well start with this cylinder. And the formula for the volume is pi times r squared times height. So it's the radius is 9, so 9 squared times the height, which is 30. And when we work that out, we get 7,634.070, blah, blah, blah. Next is the hemisphere. To find the volume of the hemisphere, well, the volume of a sphere is 4/3 times pi times r cubed, but because it's a hemisphere, we just times that by 1/2. So it's 1/2 times 4/3 times pi times r, which is the radius, which is 9 cubed, and that gives us 1,526.814, blah, blah, blah. And so the total volume is 7,634.070 blah 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 plus the 1,526.814 blah blah blah, which equals 9,160.884 blah blah blah. It says it wants it 2 decimal places, so when we round that we get 9,160.88. To find the error interval, I start by just drawing a number line, and we're going to put the number in, so 50.14. And we're going to think to ourselves, well, what would the next number down and the next number up be? Well, it's the nearest hundredth of a gram, so the next number down would be 50.13, and the next number up would be 50.15. Then to find the lower bound and the upper bound, or the highest and lowest it could be, we just find the halfway points between those two. And so the halfway point here is 50.135, and the halfway point here would be 50.145. So the lowest it could be is 50.135, the highest it can be is 50.145, and it asks us to use W for the weight, and we're going to show this with inequalities. Now it can be 50.135, so it's larger than or equal to 50.135, but it can't be 50.145 exactly, otherwise it would round to 50.15, so we don't put the line underneath the inequality. So what's happened here is that the company's increased the amount of sweets by 15%, so we're just going to focus on that and work out what the multiplier would be first. So they started off with 100%, and they added 15%, and then therefore they ended up with 115%. And to find that as a multiplier, we get the 115 and divide it by 100, and that gives us 1.15. So that is the multiplier they used. Now they used that multiplier on the original amount, and they times it by 1.15, and they got the answer of 69. But if we're working the other way to find out what they times by 1.15, we get that 69 and we divide it by the multiplier. So if we want to work out what the original number was, we divide it by the multiplier, and that gives us 60. So the answer will be 60. To find the median, we need to first of all find out what the highest cumulative frequency is. So it's 20 altogether, 20 rocks altogether, and then we halve that. So we go to the 10 here, and all we need to do is draw a line across from 10 and stop where it hits the line and draw a line down from there. And that to me is roughly, what is it, about 17, because the axis is going up in twos, and so it means the median is 17. This question relies on the fact that you know what the equation of a circle is. The equation of a circle is x squared plus y squared equals r squared. Now r is the radius of the circle. So when I rewrite this and I write it with our 16 there, we can actually rewrite 16 as 4 squared. Okay, comparing this equation to this equation, we can see that r is 4. Now this equation, the x squared plus y squared equals r squared, gives a circle with the centre at 0, 0, at the origin. So it means that the radius will be 4, so the circle will go all the way up here, all the way across here, all the way down here, and all the way across here. Now, I am really, really bad at drawing circles, and so what I would recommend you do is use a compass and measure out 4 and join these up. I'm going to try my best. I don't have a compass that works with this graphics tablet, but I'm going to try and draw somewhat of a circle. There we are. That's probably the best circle I'm going to draw. So what you do is you just get a compass and put the point at 0, and then you would measure out 4 units. So measure it between the 0 and the 4, and then just draw a perfect circle round. We're first of all going to find the multiplier for this question. So we start off with 100%. It's a compound interest of 7.2%, so we're going to add 7.2% on, and that will give us 107.2%. Convert that to a decimal or a multiplier by dividing it by 100. That would be 1.072. So that's our multiplier there. Okay, so we know that every time we times something by 1.072, it's going to increase by 7.2%. So we're going to just make up a number. So let's say £100. It doesn't actually matter which number you pick. And what I'm going to do is I'm going to type in £100 into my calculator, and then I'm going to type the equals button. I'm just going to press the equals button, okay, which sounds a bit weird, but I'm going to type in 100 into the calculator, press equals. Then what I'm going to do is I'm going to times the answer, so I'm going to press the ANS button, times 1.072. Okay, so I'm going to talk you through that again. So we're going to put the 100 into our calculator, then press the equals button, and then type in answer times 1.072. Now, every time we then press the equals button, we're going to increase the number by 7.2%. So we press it once and we get 107.2. Press it again, 114.9, again 123.1, etc., etc. And you keep going. Now we're looking to see when the money is doubled. So we're counting how many times we've got to press the equals button until it doubles the money. So after 9 years, after 9 presses of the equals button, we get 186.9, and then press it again and we get 200.4. So it's going to be 10 years to double the money. Whenever we're asked to compare two box plots or two cumulative frequency graphs, or a cumulative frequency graph and a box plot, you're always going to be comparing two things. You're going to be comparing the median and the interquartile range. Now if we do a little table, like a good table, and we've got male and female, and we're going to work out the median, which is the first thing we have to compare, and the interquartile range. And it can actually just be the normal range. We don't need to pick the interquartile range. So the median for male is this line here, this bit here. And if you look down, that is 22. And for females, it's this one here. If you look down, that's 18. And we just go write a sentence. So you say something like the median is higher for males, brackets 22, always show your values, than for females, brackets 18. Okay, easy. Next we're going to do interquartile range. Interquartile range is slightly harder because you need to do the distance between the upper quartile, which is this line here, and the lower quartile, which is this line here. And so that would be 24 take away 19, which would be 5. And for the females, it would be 28, which is this one here, take away 16, which is this one here, and that will give you the answer of 12. So the next sentence we say is the interquartile range. They don't mind you writing IQR, that's absolutely fine. Is, now you can say lower for males or higher for females. I'm going to say lower for males, brackets 5, than for females, bracket 12. Now the median is basically on average the males are higher. Okay, so it's just an average, says on average they're higher. The interquartile range is an interesting one. Anything to do with range is about consistency. So it's actually quite good in many instances to have a lower interquartile range because it just shows you're more consistent. So you say the sentence could be that the males are more consistent because the interquartile range is lower. Generally speaking, the higher the median, the better. The lower the interquartile range, the better. Apart from if you're talking about things that like the time it took you for a race, you kind of want the median to be lower. Still, you want the interquartile range to be lower because you want to be consistent. So sometimes it's easier just to do a quick diagram to see what's going on. So I'm going to say that the house is here and the shop is here. And so this person is walking to the shop and then they walk back from the shop, but they don't walk as much. And we're looking to see the maximum distance the person is from their house. So we're looking to maximize this distance here. So we want this distance to be the biggest it can be. So we can see that we want to maximize this distance here, so that the shop is a long way away, and we want to minimize this distance here because we don't want them to have made that much distance towards their house because we want to maximize that distance. So we're going to find the maximum for the 3,750. So it's to the nearest 10. And a trick you can do to find out what the upper bound is going to be is just half the accuracy. So 10 meters to the nearest 10, half of that would be 5. And then just add that on. So that's going to be 3, 6, 5, 5. That's the upper limit. We want to minimize this distance, which is 120. So the accuracy is still 10 because it says both measurements are to the nearest 10 meters. So we're going to halve that accuracy. 10 would be 5. And this time we're going to take it away. So 120 take away 5 would be 115. Okay, so to find the maximum distance the person is from their house, we're just going to do 3,655 take away 115, which will equal 3,540. We can write the equation of any linear graph as y equals mx plus c. So m is the gradient and c is the y-intercept. So we've got to find what the gradient and the y-intercept are. Well, I'm going to first of all try and figure out what the gradient is, because we're actually given some clues here. We're told that the line is perpendicular to the equation given. Now I'm going to rewrite this a little bit just to make it a bit clearer what the gradient of this is. So I'm going to write this as minus 1 over 12. I'm just going to leave a bit more of a gap there. Minus 1 over 12 x plus 12. And you can see that the number before the x, the coefficient of the x, is minus 1 over 12. But we're not told that it's parallel to that, so it's not the equation that we've got is not going to have the gradient as minus 1 over 12. We're told it's perpendicular. Now, when two things are perpendicular, to find the gradient of the other one, if we know one of them, you've got to change the sign and find the reciprocal of the fraction. So to find our gradient, we're going to change the sign, so it's negative, so our gradient is going to be positive, and we're going to flip it. We're going to find the reciprocal. Reciprocal of 1 over 12 will be 12 over 1, or just 12. So the gradient of our line is going to be 12. To find the y-intercept, we're going to use the points given to us. So we've got x equals 3 and y equals 4 for a point on our line. We're going to substitute those into the equation we've got. So it's going to be 40 equals 12 times 3 plus c. Put in our solving lines. 12 times 3 is 36. And we're going to take away that 36 both sides. So it's going to be 4 equals c, or c equals 4. So our equation will be y equals 12x plus 4. I'm going to start by labelling this triangle, and so I'm going to pick a lowercase a here, uppercase A, I mean, for the angle, and then we go opposite it to mark the length with a lowercase a. I'm going to do a capital B here, and then go opposite it to do a lowercase b, and then obviously a capital C here, and then a lowercase c here. Now notice the C's aren't involved in this question at all. It's just the capital A and the lowercase a, and the capital B and the lowercase b. Now when you've got two pairs of angles and sides, you're going to be using the sine rule. Now, the sine rule is either sine A over A, or it's A over sine A. Now, when we're looking for a length, we put the length on the top. So it's going to be lowercase a over sine capital A equals lowercase b over sine capital B. Okay, so we're going to fill in the values. So A is x, capital A is 38, lowercase b is 4, and uppercase B is 67. Now you'll only ever sine an angle, so if you ever put a 4 in there or something, that's not going to be right straight away. Okay, let's work out what 4 over sine 67 is, and that's 4.345, blah blah blah. So we're going to solve this. It's going to be a nice and easy solve today, because all we need to do is times both sides by sine 38. And so that will give us 2.675, blah blah blah. And when we round that, we get 2.68. So we're going to start off just by copying down the same equation. And we're asked to make B the subject. So we're going to put our solving lines in. So the first thing we need to do is get rid of this 10 here. So we're going to divide both sides by 10. And that will mean we have a fraction here, a over 10. And we've got the square root b over 3. Now we need to get rid of that square root. So what I'm going to do now is square both sides. Now to square a fraction, we square the top of the fraction and we square the bottom of the fraction. 10 squared is 100. And that will equal b over 3. And we want to get rid of this next, so we want to times both sides by 3. To get rid of a divide by 3, we times both sides by 3. Now with a fraction, when you times it by something, you actually just times the numerator, the top, by that. So it's going to be 3a squared over 100 equals b. So b is 3a squared over 100. So we're given the equation of the line, which is y equals ka to the power of x, and we're given two coordinates. So we're looking at this first coordinate and put that into the equation. So y is 10 equals ka to the power of x, which is 1. And we're going to do the same with the other coordinate. So we've got 40 equals ka to the power of x, which is 3. Now look at what's happening to both sides. Here we're multiplying by a squared. So a to the power of 1 times a squared is a to the power of 3. And on this side we're multiplying by 4. So we have to be able to conclude that a squared equals 4. And if we square root both sides there, a must equal 2. So if a equals 2, we can just put that into the first equation here. So we've got 10 equals k times 2. And divide both sides by 2, and we get 5 equals k, or k equals 5. So our answers will be k equals 5 and a equals 2. Now check that works. So let's have a look at this second coordinate, and we're going to do y equals, and we're going to do 5 times 2 to the power of 3. 2 to the power of 3 is 8. 5 times 8 is 40. So we know that our equation works. So we first of all need to work out the frequencies in each of the bars, and we know that the frequency density is proportional to the frequency over the class width. So we're just going to go through each of these bars and work out what the frequency is. So all we need to do is times the frequency density by the class width. So 4.8 times 10 is 48. The second one is 0.4 times 10, which would be 4. And then the last one will be 0.8 times 5, which will also be 4. Work out the total frequencies. So it would be 48 plus 4 plus 4, which will be 56. So 56 in total, lines in total. And they only want to see the largest 20%. So we're just going to work out 20% of 56, which we can do, we can just multiply it by 0.2, and that'll give us 11.2. Now you can't have 0.2 of a line, so we can just round that to 11. When solving simultaneous equations graphically, the solutions are just where the two graphs meet. So we've got y equals x plus 4 drawn, and we've got y equals x squared minus 2 drawn. So the solutions will be here and here. So the coordinates will be x equals minus 2 when y equals 2, and x equals 3 when y equals 7. To find the inverse, we're going to first of all, instead of writing f of x, I'm just going to replace it with a y. And the trick of finding the inverse is to swap over the x and the y. So we're going to swap them over. I'm just going to do it over to the right hand side over here, so we've got a bit of space. Now the challenge is to get it so that it's y equals rather than x equals. So we're going to start off by multiplying both sides by 4. And that will give us 4x on the left hand side, and it will get rid of the fraction on the right hand side, which was kind of the point. Next we're going to get rid of that minus 6, so we're going to add 6 both sides. And then finally we're going to get rid of that times 5 there by dividing both sides by 5. So we've got 4x plus 6 over 5 equals y. And we use y as a replacement for the inverse function of x. And so we're just going to say the inverse function of x, which is what that minus 1 means. It means inverse, equals 4x plus 6 over 5. A normal sine wave starts at 0, goes up to 1 at 90, down to 0 at 180, down to minus 1 at 270, and then back up to 0 at 360. But here we're given a plus 45 inside the function. Now, a plus 45 actually does the opposite of what you think. You would think that it would move it right 45, but it doesn't. It moves it left 45. So each of these points we're going to move to the left by 45 degrees. So instead of at 91, this is now going to be at 45, 1. And each of these are just going to move left 45 degrees. Now 45 degrees is 2 squares, so it's just 2 squares worth of moving left. And so we get a really horrible start to this because we don't really know where it's going to start. It's going to start somewhere there. And then we've got a nice U shape, and then down to here. These types of graph are not the easiest to do because they're stretched out, but make sure you have a U shape at the bottom there. And then we kind of guess here that it's going to go somewhere there. So when we have two equations that are both linear, we obviously do solving through elimination. But here we've got a kind of quadratic-y, kind of circular graph on our second one. So we're not going to be able to use the method of working downwards and eliminating the x or the y's. But here what we can do is we can solve through substitution. This first thing says that instead of y we can write 5x. So what we're going to do is just write out the second equation, but instead of y we're going to write 5x. So we've got x squared plus, and instead of y we're going to write 5x, we're going to put it in brackets because we're going to square it, plus 10x equals 111. So we can actually create a quadratic from this situation. So we're going to just square that. So that's going to be 25x squared plus 10x equals 111. I'm going to just put our solving lines in. It's not much solving to do, because all we need to do is take away 111 from both sides to get it equal to 0, which we need to be able to solve the quadratic. So x squared plus 25x is 26x squared plus the 10x, and we're taking away 111 from both sides, so that will equal 0. So looking at the question, it says to 2 decimal places. It's a calculator question. Chances are we're going to be using the quadratic formula. So for the quadratic formula, we need to find out what a, b, and c are. A is the coefficient of the x squared, which is 26. B is the coefficient of the x, which is 10. And c is the number on its own, which is minus 111. So we're going to substitute those into the quadratic formula, which is x equals, and then we put our fraction in, and we've got minus b, and I always put them into brackets, plus minus, and you'll see why if you ever have negatives, so you can get in real problems when you have negatives. It doesn't take much longer to put them into brackets. Minus 4 times a, which is 26, times c, which is minus 111. And then all of that over 2 times a, which is 26. So we're going to do this once with a plus there. And so when we have a plus there, we got 1.882, blah, blah, blah. And when we do it with a minus there, we get minus 2.267, blah, blah, blah. But the problem is those are x values, and when we solve, we've got to also find out what the y values are. Well, we actually have a really nice way of finding out the y value, because if you look at this first equation, it says that y equals 5 lots of x. So all we need to do is multiply these x values by 5. So we're going to times that first one by 5, and we get 9.414, blah, 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 times the second solution of x by 5, and we get minus 11.337, blah, blah, blah. And so when we round those to 2 decimal places, which is what the question asks, we can have 1.88 and 9.41, and we have minus 2.27 and minus 11.34. Here we've got a cubic graph, and we're asked to find out what the equation would be if it was in this form here. So first of all, notice that we've got a negative cubic. A positive cubic looks like this, so we've got a negative cubic, and there is a minus sign there that just deals with that. So we don't need to worry about the fact it's a negative cubic, because that minus sign just means it's negative, fine. Next thing we want to do is find the roots. So the roots are where the line crosses or touches the x-axis. So here we can see it touches it at 6, so when x equals 6. And here, now this is an interesting one, it actually touches it twice. It touches it at minus 7 the first time going down, and then it touches it at minus 7 going up. So there's technically 2 roots there. Sort of one root, but it counts twice because it's going down on one root and then up on the other root. So with these, what we need to do is we need to make sure that at x equals 6 and x equals 7, minus 7, that this equation, the whole thing equals 0. So if we imagine a, what does a have to be to make this whole thing equal 0? When we look at this, the fact that a root is at 6. Well, if we put a at minus 6, we get x minus 6 in that bracket there. And if we put in the value of 6, then it's 6 minus 6, which is 0, and so the whole thing is 0, because anything times 0 is 0. So if a is minus 6, let's have a look at b. So what does b have to be? Well, if that's minus 7, if we put b as plus 7, then when we substitute in this minus 7 here into the x, we get minus 7 plus 7, which is 0. So if b is minus 7. Then the whole, plus 7. Then the whole thing will be 0 at x equals minus 7. And for the c, we're looking at that last root. Again, it'll be the same, won't it? It'll be x plus 7. Now, you might ask the question, how do you know which is a, which is b, which is c? Actually, it doesn't matter. We could put a at minus 6, and a at 7, and b at minus 6, and c at 7. As long as one of these is minus 6, one and two of these are 7, you'll always get the right answer. Now notice the format that it wants the answer does not have a square root at the bottom, so we are going to be rationalising the denominator with this. So I'm just going to write out the question, just so we've got a start. And notice here we've got this 6 plus root 2. Now you might think you rationalise the denominator by timesing top and bottom by root 2, and that would get rid of the root 2 there, but it would actually create a 6 root 2 at the bottom, so it won't rationalise the denominator. The trick here is, imagine that the bottom here is a bracket, and what you want to do is times top and bottom of this fraction by the same bracket, but with the different sign, the opposite sign in the middle. So instead of 6 plus root 2, it's going to be 6 minus root 2. So we're going to have 6 minus root 2. Okay? And when we do that, we can imagine that there's going to be brackets at the top as well. We've got 2 plus root 2 and 6 minus root 2 at the top. And then we've got the 6 plus root 2 and the 6 minus root 2. Now, the reason why we do that is you will see when we expand the bottom one, but I'm going to start with expanding the top one. And it doesn't really matter which method you take to expand it. I'm just going to use the grid method because it's a little bit clearer maybe. And so we've got 2 plus root 2, and we've got 6 minus root 2. So 6 times 2 is going to be 12, and that's going to be 6 root 2 minus 2 root 2, and then that would be minus and a positive is a negative, and then root 2 times root 2 is just going to be 2. And so when we add these two together, we're going to get 10. When we add these two together, we're going to get plus 4 root 2. And I'm going to now do the bottom one. So this one was this expansion here, and I'm now going to do this expansion here, and we're going to do it down here. And so we've got 6 plus root 2 and 6 minus root 2. So 6 times 6 is 36, 6 times root 2 is 6 root 2, 6 times negative root 2 is just negative 6 root 2, and then we've got a minus and a positive make them negative, and then root 2 times root 2 is just minus 2. And so when we add them together, we've got the 36 and the minus 2 there, so that would be 34. And then 6 root 2 take away 6 root 2 is just going to be nothing. So that actually expands to be an integer, not a surd. And that's why we picked the opposite sign, is because whenever we do that, we get rid of the root 2 and we just get a nice number at the end. Okay, so when we put those in, and we end up with 10 plus 4 root 2 at the top, which is our answer here, over 34, which is our answer here. And let's just make that a bit nicer. There we are. And that's our answer down here. Now we're looking to see whether we can cancel at all, and if you look, we can actually divide everything by 2. So divide the bottom by 2 and we get 17. Divide the 10 by 2, we get 5, and we've got to divide all 3 terms by 2, so we get a 2 there. So we actually end up with 5 plus 2 root 2 over 17. So our missing numbers, looking back at the question, A would be the 5, B would be 2, and the C 17. So we're told to complete the square, so we're just going to get this equation here and just complete the square for it. So the first thing I'm going to do is remove the coefficient of the x squared. So we want just x squared and sine. So I'm just going to make a set of brackets, and we're going to factorise it out of the x squared and the minus 24x, so that would be minus 8x. Then we've got the take away 15. Next, I'm going to complete the square, so I'm going to do this in different colour just so we can see what's happening. And to do this, we have a bracket with an x minus half of the coefficient of the x, so that'd be 4 squared. Now if we expand that, we get x squared, brilliant, minus 8x, fantastic, and then we have a plus 16, so we need to remove the 16, so we're going to take away the 16. Next we're going to expand the bracket with the 3 in, so we're going to have 3 brackets x minus 4 squared, or close bracket squared, minus 48, minus 15, and then we're just going to tidy that up by adding the numbers together, so that would be minus 63. On our graph, we're going to draw the graph of y equals 3x squared. Okay, simple. And we don't need to, it's only a sketch, so we don't need to worry about exact values, but we do know, the most important thing is we know it goes through the origin, so it hits here at 0, 0. That's the important thing, okay? Because we know that if we called that f of x, then the situation we've got here, well, it's going to be f of x minus 4, okay, because we've got the minus 4 there. So that means it'll move to the right 4. Okay, and it will also, we've got to worry about that minus 63 as well. And if we had f of x minus 63, we know it goes down 63. So in total, we have f of x minus 4 take away 63. That's what we have in total. So we're moving just 4 to the right and then 63 down. So instead of 0, 0, our minimum point will be at 4 minus 63. So to find the shaded part of this diagram, we need to first of all work out the volume of the smaller cone, which is at the top, then work out the volume of the larger cone, which is the whole cone shown, and then take them away from each other. So the radius for the smaller cone is 4 and the height is 5. And the radius for the larger cone is 20, and the height is the 20 plus the 5, so it would be 25. So I'm just going to label them A and B. And so why don't we work out the volume for B first? And the formula for the volume of a cone is 1/3 pi r squared h, with h being the perpendicular height. So it's 1/3 times pi times 20 squared times 25, which is going to be 10,471.975, blah, blah, blah. We're going to work out the volume for A, and this time it will be 1/3 times pi times the radius now is 4, and the height is 5. So that will be 83.775, blah, blah, blah. So to work out the shaded bit, we're just going to do the volume for B, take away the volume for A. So it's going to be 10,471.975, take away 83.775. And all those I'm going to keep in the calculator to keep the accuracy. And that gives us 10,388.199, blah, blah, blah. And to 2 decimal places, it's going to be 10,388.20. So we're finding the area underneath this graph, and that's how we're going to estimate the distance, because the distance is the velocity times the time. And so if we work out the area under the graph, then we've got the distance. But the issue is that we don't understand things like calculus yet, and we've got to use this thing called the trapezium rule. Now for the trapezium rule, what we do is we draw these lines up and we draw little trapeziums, like so, all the way up it, and in regular intervals. So here you can see the interval is every 2 seconds, and we draw these little trapeziums. Now it's often helpful to actually label them, so I'm going to label them A, B, C and D. And the formula for a trapezium, or for the area of a trapezium, is half brackets A plus B close brackets times H. Now A and B are the parallel sides, and H is the perpendicular distance between them. So let's do this for the area of A. So it's going to be half brackets. Now A and B are the parallel sides, so it's going to be this side here and this side here. So that would be 2 plus 1. H is the perpendicular distance between them, so this bit here. So it's on its side, so the height is actually the width, isn't it? So we're going to times that by 2, and that gives us 3. Okay, and you notice here that the half and the times 2 actually cancel each other out, so all we need to do is just add the A and B's together. So to find out what B is, we're just going to add the 1 and the 2, and B will equal 3. To find out what C is, it's 2 plus 5, which is 7, and to find out the area of D, it's going to be 5 plus 10, which is 15. So that's a bit of a quicker way of doing it than having to type it into the calculator each time. Then to find the total area, it's just going to be all of those added together, which will be 28. Now notice, this is useful for some questions, notice that actually there's a bit of a gap here, and I'm just going to shade it in green. It's a bit of a gap between our trapezium and the actual distance under the curve. So here the trapezium is actually adding on a little bit more area than we want it to. And what you'll find is a curve that looks like this, the trapeziums will actually add too much, so the area will be too big, and for curves like that, the trapeziums will actually not give enough area. So sometimes there's questions on whether it's an overestimate or an underestimate, and that's how you can tell. Okay, so we're going to start by creating a cuboid, just so we can kind of visualize what's going on a little bit easier. And so the lengths on the cuboid, it says, are 14, 10 and 8. Doesn't matter which way around. Now the longest part of the cuboid will be the diagonal across it. So if I just show a diagonal there, and it doesn't really matter which one we pick. Ooh. I could pick this one here, go diagonal like that. They're all the same length, all the diagonals across. So the rod will be, if it's the maximum length of the rod, it will be along this diagonal. So we can first of all have to work out what this length here will be, and then we can use the fact that this is 8 here and work out what the length of the diagonal is. So I'm going to call this X, and I'm going to call the diagonal Y, just so we've got something to refer to in our working out. And it might be helpful that this side here is 10. So we've got a right angle triangle, because this is right angled here, and we're looking for the value of X. So we know that we're going to be using Pythagoras, because we've got 2 lengths and we're looking for a third length. So it's a squared plus b squared equals c squared, so it would be 10 squared plus 14 squared equals c squared, and it's actually not c, we've called it x, so what do I stay consistent, equals x squared. So I'm going to do 100 plus 196, which would be 296 equals x squared. And get our lines in. Should be quite easy because we just need to square root both sides. So I'm just going to square root that, and we get an answer of 17.20 blah blah blah. Now I'm going to keep that value in the calculator itself because I'm going to use that to find out what y is, our diagonal. So the next thing we're going to do is, we know what this is, and this creates a right angle triangle here, and so we're just going to do exactly the same thing again. A squared plus b squared equals c squared. Our a is 8, so 8 squared plus, and then we've got 17.20 blah 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 squared equals, and then we're looking for y, so y squared. Now if I square the value that's in my calculator from before, the 17.20, and if I just click square it, it will put it back to 296 because I've square rooted it and then I'm just squaring it again, so it would be 64 plus 296 equals y squared. So I'm just going to add them together, which will be 360. And again, I'm just going to put my solving lines in. Not too difficult to solve this. Make it a bit nicer, because I'm just going to square root both sides. So I'm going to square root this, and it gives me the answer of 18.9736 blah 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 equals y. Now it says it wants the answer to 2 decimal places, so it would be 18.97 to 2 decimal places. Now a different way we could have done this is we could have worked out y straight away by working out the, like, I don't know what to call them. I'm going to label them A, B, and C. So A, B, and C. And what you can do is you can do the y squared equals A squared plus B squared plus C squared. It's basically the width squared plus the length squared plus the height squared. And so we would have had 14 squared plus 10 squared plus 8 squared. And when you've done that, you would have got 360, and this would be y squared equals. And then when I put the solving lines in, I would have done the same thing, square rooted both sides, and you obviously would get the 18.973 blah 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 again, and then you would have written down the answer. So there's 2 different ways of doing that. Obviously this way is a lot quicker, but you have to just remember that if you've got 3 lengths on the cuboid and you'll ask for the diagonal, then this formula here can be a much quicker way of finding the answer. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.